Welcome to RCC's Math Tape 086, Graphing Linear Inequalities. On this tape we will work with inequalities in two variables. I expect you already know how to solve an inequality in one variable. If you have forgotten this skill, you can review Math Tape 074 to renew your acquaintance with inequalities in one variable. You will need to have graph paper handy for this material. Also, as always, be sure to take your notes carefully and thoroughly. Any place you don't understand, you need to mark on your notes so that you can ask for help when you go to the lab. Also, any exercises you miss need to be marked so that you can get help from the lab instructor or a tutor when you go to the math lab. Now let's begin. We have only one objective on this tape, and that is to graph linear inequalities in two variables. Graph linear inequalities in two variables. Let's recall what we know about a linear inequality in one variable. So here's a quick review of linear inequalities in one variable. Recall that a linear inequality in one variable might be, for example, something like x is less than 2. We graph x is less than 2 using a number line. On that number line, we find a convenient location for the important number 2, which is our boundary number, and we place it somewhere so that there are things both below and above the 2. We then circle the 2 since 2 is not included, and shade in all of the values that are less than 2. Since 1 is less than 2, 1 will be shaded in, so will 0, so will all the numbers to the left of 2. We shade in all of those points, shading in the arrow nice and heavy so that it's clear at a glance that we use all the numbers that are less than 2. We have the boundary point, x equals 2, the boundary point at x equals 2. It is open because of less than, open for the less than, and the shaded portion shows the solution. So here's our whole story. X is less than 2, has a boundary point x equals 2. The boundary point is shown open because less than does not include the 2. And the shaded portion shows the solution. Remember that if we had had x is less than or equal to 2, we would fill in the dot. It would be closed, filled in, for less than or equal. By comparison, a linear inequality in two variables might be something like y is greater than 2x minus 1. Notice that we have two variables, y and x. Y is greater than 2x minus 1. Now, we're not going to go through the whole process just yet. We're simply going to compare the idea with the one we've just looked at. So, y is greater than 2x minus 1. We'll have a boundary line. The boundary line is y equals 2x minus 1. Notice that the boundary is found by replacing the inequality symbol with an equals mark. The boundary line is y equals 2x minus 1. Now our boundary will be a line rather than a point. The line will be dotted for greater than. The dotted line is rather like the open point. The dotted line for greater than. And the shaded portion, whatever that looks like, we'll see that in just a few moments, shows the solution. So we will have, for an inequality in two variables, a boundary line rather than a boundary point. Instead of having an open circle or an open dot, we will have a dotted line to show that the line, the boundary, is not included. And once again, we will have a shaded portion and we'll determine where that is shortly. The shaded portion shows the solution. Let's go directly to the procedure that we'll follow, and then we'll use this inequality as an example. The procedure to graph a linear inequality in two variables. To graph a linear inequality in two variables, step 1, solve the inequality for y. Solve the inequality for y. This is just like solving an equation for y, except that you must follow the rules for solving inequalities. Step 2, for the boundary line, replace the inequality symbol with equals. For the boundary line, replace the inequality symbol with equals. Step 3, graph the boundary line. You will draw dotted for less than or greater than, solid for less than or equal, or greater than or equal. Graph the boundary line. A dotted line or a solid line. Dotted for less than or greater than, solid for less than or equal, or greater than or equal. This much will tell us where the boundary line is and what it looks like. Then we must decide what to shade. Step 4, shade above the boundary line if y is greater or y is greater than or equal. Above, greater. Y gets greater as we go up, and so we shade above the boundary line if y is greater than or y is greater than or equal to. Then, of course, shade below the boundary line if y is less than or y is less than or equal. Shade above the boundary for greater than, shade below the boundary for less than. One more step. Step 5 is check. To check, and all we're checking here is whether we shaded the correct side. Choose a representative point. Choose a representative point from each side of the boundary line. Choose a representative point from each side of the boundary line and test it in the original inequality. Choose a representative point from each side of the boundary line and test it in the original inequality. We will choose a point above and a point below. We test each one in the original inequality. The shaded side must test true. So the representative point from the shaded side must test true. The unshaded side, false. The shaded side must test true. The unshaded side, false. This is a lengthy procedure. It's much harder to write out than it is to do. Let's do the graph of the one that we looked at just a moment ago as our example. Example 1, we're to graph y is greater than 2x minus 1. Y is greater than 2x minus 1.